Good morning. Hope you all are having a great Wednesday. So we're going to start out with this video continuing section 1.3. The figure shows a gate with diagonal braces. Segment MO bisects segment NP at point Q. If the length of PQ is 22.6 inches, find the length of PN. So it's really important that we tune into this part right here, not read past that. Don't read past it so quickly. Segment MO bisects segment NP. So here's MO, here's NP. And MO bisects NP. So that means that NP is the segment that got bisected. MO was the bisector. So if MO bisects NP, then these pieces of NP are equal to each other because they got bisected at point Q. So Q is the midpoint, and so it's exactly in the middle of N and P, which makes NQ and QP equal to each other. Okay, now we can read a little further, and it says the length of PQ is 22.6 inches. So from P to Q is 22.6 inches. Well, if these two segments are the same, they got bisected, then NQ is also 22.6 inches. And then they want us to find the length of PN. So P to N, whoops, I kind of did N to P. So from PN, they want us to find that. So let's write, this is segment addition. Let's write it out with symbols first. How about we say NQ plus QP equals NP. Or going the other direction, we could say PQ plus QN equals PN. And maybe you like that second way better because that's the way they're discussed in the book. So we know PQ is 22.6. We just talked about QN being the same length, 22.6. And that's going to equal PN, which is PN, or we could put X there. Either one is great. These are on like the same side, so they are like terms, so we're just going to add them together. Lining up that decimal. Looks like it's 45.2 inches for PN. For this next example, they tell us point S is the midpoint of RT. So this is segment RT. And point S isn't just on this segment, it's right in the middle. So we'll put it where we think the middle is. And to show that it's the midpoint, we'll use our tick marks. So those two parts are equal. And they have this labeled as 5x minus 2. And this labeled as 3x plus 8. I don't think I did this one with you all in class. I think I did one similar, but I apologize if I did the exact same one. I don't know RT, and all they want us to find is the length of ST. So I can't work it like segment addition because even though I know the part and the other part, I don't know the whole thing. So we have to go a different route. Well, this time we know that these two parts are equal to each other. So if they're equal to each other, we'll write them as an equation. So those are the two pieces that are equal to each other. I like to get the x's on the same side first. And I didn't talk you through that. I like to add the 2 and then divide by the 2. So x is 5. That's not the answer though. The answer is what's the length of ST. So ST is 3x plus 8. So we can evaluate that by putting that value in for x. So that is 3 times 5 plus 8. Order of operations, that's 15 plus 8, which is 23. Okay, these next two things that I'm going to discuss are reviews from algebra. So we have the midpoint formula. and its midpoint equals x1 plus x2 over 2, comma, y1 plus y2 over 2. This is the midpoint formula to find the point in the middle of two given points. I wish I'd given myself more room. One of them is x1, y1, and the other point is x2, y2. And this is your midpoint formula. And if you want to find the middle, it's like finding the average. So you're going to add the x's together and divide by how many there were. That's all it is. And it's remembering that this is a point, so there's a comma in the middle to separate the x coordinate from the y coordinate. So if we want to find the midpoint of our s, oops, let's don't use yellow. I think this will come back to you from algebra last year. If r is 1, -3, and s is 4, 2. Okay, we want to find the midpoint of this segment. We've got this handy-dandy midpoint formula. All we have to do is plug into it. Every point has an x and a y coordinate. We need some way to tell these 2 points apart, so we call one of them x1, y1, and the other one x2, y2. So all we do now is we take these values and we plug them into this formula. So the midpoint is x, so I'm reading this formula up here that I've boxed in yellow. So it's x1 plus x2. So for us, it's 1 plus 4, all over 2, comma, y1 plus y2. So for us, it's -3 plus 2, all over 2. Then you just simplify the x's. You would get 1 plus 4 is 5 over 2. I'm okay with that answer. And the y's is -1 over 2. If you like decimals, then I am okay with 2.5 and -0.5. Both of these are great for me. And lastly is distance formula, which is also a review from last year's algebra. You would use distance formula. It's used to find the distance between 2 points. Or in another way to say it is it's used to find the length of a segment. And you know, a segment is made up of 2 endpoints and all the points in between them. And this is the same idea where one of the points is x1, y1, and the other point is x2, y2. The distance formula, I've got a goofy song that I sing, and it's to the tune of Pop Goes the Weasel. I apologize ahead of time for singing. Oh, actually, I got that confused. I don't have a song for this. I have a song for the quadratic formula. So you don't have to hear me sing. This is the d equals the big square root of x2 minus x1 squared plus y2 minus y1 squared. So this is our formula that we want to write down and try to commit to memory. And when you come in to class, I will do a couple of examples with these. So let's, for example 4, Find the length of segment PQ. Do you see that's all I had to write? Find the length of segment PQ with endpoints P25 and Q -4,8. Oh, you want me to find the length? That means distance formula. Whenever they ask me to find the length, I'm thinking about distance formula. So D equals big square root x2 minus x1 squared plus y2 minus y1 squared. Every point has an x and a y, just like with midpoint, just like with slope. You're going to let one of them be the x1, y1 point, and the other one is the x2, y2 point. And then we just fill this in. So D equals square root x2, which is -4, minus, x1, which is 2, squared, plus y2, which is 8, minus y1, which is 5. Now the order of operations says we need to work inside this big grouping symbol, which is the square root. And inside the square root, we've got some parentheses. So we're going to work inside the parentheses first from left to right. And then we're still working underneath the big square root symbol. And we have numbers raised to powers. So exponents we need to do next. -6 to the second power means -6 times -6, so that's positive 36. If you do it on your calculator, make sure you use parentheses, because this is positive 36 and this is -36. Please make sure you're using parentheses if you do it on your calculator. And 3 squared is 9, 3 times 3. Under that square root still, we're going to add now, and we get 45. And I'm okay if we leave it as the square root of 45 because we haven't learned how to do square roots yet. So you don't have homework over this section yet, but I wanted to review you on distance and midpoint so that we will be more familiar with it. And we'll do this section Thursday after you all take your quiz. Remember, if you do not feel comfortable with your quiz review, please come in and see me Thursday morning before school starts so we can go over a few and help you to feel more comfortable.